All right, ladies and gentlemen, today we're going to be talking about something called interval notation. And so it kind of goes with inequalities. So I'm going to show you an example. If I ever said, hey, tell me the numbers between 3 and 5, you obviously can't list those numbers, right? You would have to say, hey, x is going to be less than 5, but also greater than 3. This is how you would put that in interval notation, right? You can also put it in a graphical notation, which is actually this graph right here, this number line. The reason why it's hard is that it's an infinite set. An infinite set has an unlimited number of elements. There are infinitely many points in between 3 and 5, right? Now, if there had been a finite number, which means that it's a definite number of elements, you can just list them. You know what I mean? So like just listing numbers, those are really easy to list. So sometimes we go ahead and list numbers in what we call roster or list notation. But in the case that we kind of started with down here, we have infinitely many numbers between 3 and 5. We cannot list them. So what we use is we use something called inequality notation, which looks like this, or something called interval notation, which looks like this. So you can see right here where I'm about to star, right here, this shows you 1, 2, 3, and also 4 different ways to say the same exact thing. X lives between 3 and 5 over here. X is bigger than 3 and less than 5 right here. Or interval notation. It looks like a point, but actually what interval notation is it thinks about endpoints. So it has 2 spots right here, and these basically tell you an endpoint of an interval. So we're saying the farthest left point on our number line is 3, the farthest right point is 5, and then we decide symbols to use. So brackets, these things right here, are used when we have a closed-in circle on our number line, and an open circle on our number line would mean we put a parentheses. So in our example, we put parentheses because they're both open circles. Now, let's say I had something like this. And let's say this was at 3 and this was at 5. To put this in interval notation, we would say, okay, my left number is 3, my right number is 5, but I need a bracket around the 3 and a parentheses around the 5. So you don't have to match the symbols, they just have to reflect what the number line would say. So we're going to use interval notation for the rest of the year. So we kind of have to start to understand what it means. So let's look right here. Interval notation is here, and we're going to translate it, or sorry, inequality notation there, and then we're going to translate it to interval notation. So for example, we always have 2 kind of spaces. What's the leftmost number? Well, x exists between 3 and 8. So 3 is the left number, 8 is the right number. And because these would be open circles on the number line, we use parentheses there. Let's look at this next one. X is greater than -4, but less than or equal to 0. So -4 is going to be our left point. 0 is our right point. Okay, because this is an open circle, we're going to put a parentheses. And because this one is a closed circle, we're going to put a bracket. And so we always read from left to right in order of the number line, right? Get it right? Nope. Okay, x is greater than 5. Well, what does that look like on a number line? Well, that would mean I have a point at 5 that's open, and then it just goes to the right forever. So here's how we would write that. Well, let's see, our left endpoint is at 5, and we don't have a right endpoint. So I'm going to put infinity, because this arrow means I go on forever. Because it's an open circle, I put a parentheses around my 5, and look at this right over here. We always use parentheses with infinity. So no matter what, we'll put a parentheses around that. Last one, x is less than or equal to -2. We would have a point at -2, and it would be closed. And it's less than -2, so it goes to the left. So let's see, what's the farthest left point that we colored? Well, it's actually -infinity. It goes to the left -infinity, right? And then it goes all the way to -2 on the right. We always use a parentheses around infinity. And because there's a closed dot on the number line, we're going to use a bracket right here. So what we're going to be trying to do is basically find a left and right endpoint and then get the right symbol. So let's see, let's write these in interval notation. Let's see this first one. What's the left point? 3. There's an arrow that goes to infinity forever. Let's see, that looks like an open dot right here. And we always use a parentheses around infinity. All right, over here, let's see, there's an arrow going to the left forever here. So it's going to be negative infinity on the left because it's going forever to the left. And it stops at 5, and we're going to have a bracket because it's a closed circle. Okay? Use interval notation to represent these numbers. So in number 15 here, and again, these aren't numbered super well usually. In number 15, let's see, the left endpoint is 7. The right endpoint is 12. Look at those symbols. We're going to have an open, closed dot. Same with over here. Let's see. Look at this one to start. -6 to -4. They're both closed, so we'll use brackets. Uh-oh, we have to do a second one. That looks like it's at 5, and it's going to infinity. Parentheses, parentheses. And whenever you have 2 on one number line, you put what we call a U or union symbol between them, which basically means two at a time, essentially. All right, this last one, let's see, it goes forever to the left, so we'll have negative infinity, and it stops at -1, and it'll be a closed dot. So now we're just going to practice converting between forms, okay? So here we go. The graph of this, x is greater than 3. We're going to have an open circle, and it's always bigger. X is between -2 and 7. Sorry, you can't really see that, but let's see, we'll have a closed dot here and an open dot here. And let's see, I don't know what to do here, so I'm going to draw a number line, and it says from negative infinity until 4, I stop, and I'm going to have an open circle at that. So put an arrow going to negative infinity. All right, let's try some interval notation. Let's look at our graph. Okay, left point is 3. Right point is infinity. Let's see, open, open. Left point is -2. Right point is 7. We're going to have a closed and an open. And let's see, these are all of the point x's. Let's see, x is less than 4. And that's it. And that's all we have. I'm going to go ahead and pause. Well, let's see how much we have left. Oh, we just have these 2 examples. Just kidding. All right, here we go. Solve compound inequalities. Basically, just solve them. Divide by 2. Divide by 4. X is greater than -2. So let's see, -2, but less than 3. Open, open, boom. How would we write that in interval notation? -2 to 3. All done. Let's try one more. So 3x is greater than or equal to -12. I'm just going to divide by 3. Divide by 5. This is greater than or equal to -4 and less than or equal to 1. Those are both closed dots. And so let's see, -4 to 1, and uh-oh, these should be brackets. And that is interval notation, ladies and gentlemen, all done. Go ahead, and the homework will be to try to do the extra practice. So it is just a couple